This is the lecture number 1 for the chapter sets class 11th, and we are doing the basic for it for the chapter sets. Now first of all, we'll define what is a set. Now set is a collection of well-defined elements or objects. It is a collection or a group of well-defined elements or objects. The element should be well defined. It is denoted by a capital alphabet and this curly bracket. It is denoted by the capital alphabet and this curly bracket. I have taken a set A, capital A, which is containing the elements 1, 2, 3, 4. It is separated by this comma and the elements are 1, 2, 3, 4 I have taken, or objects. I have taken the set B, which is containing the element curly bracket and the element 2, 4, 6, 8, 10 and so on. I have taken another set C, which is containing the element A, E, I, O, U and this is the curly bracket. Set D, I have taken the elements 2, 4, 8, 16, 32. We have 5 elements in it, infinite number of elements in it, 4 elements in it. I have taken the element E or set E containing the elements 1, 4, 9, 16, 25 up to 100 I have taken. See it very carefully how many elements are there in it. 1 square, 2 square, 3 square, 4 square, 5 square and this is 10 square. So it means there are 10 elements from 1 to 100. Now we can represent a set in two forms. First is roster form and another is set builder form. Now the roster form is the method of representation of set like this. A capital alphabet, curly bracket and the elements in it like this. And the set builder form is you have to represent the set by a capital alphabet, a curly bracket, but in the curly bracket you have to write the statement like this: x such that, this is a sign for such that, x, this is a sign for belongs to, capital N means natural number, and x less than equal to 4, like this. You have to represent a set like this. Now before going to the set builder form, I am taking this collection of some elements, that is the natural number. Collection of natural number is denoted by this capital N. The collection of whole numbers is denoted by this capital W. The collection of integers is denoted by Z. The collection of natural numbers denoted by this Q. The collection of real numbers is denoted by this R. The collection of positive integers is denoted by this Z positive sign. Collection of rational number, positive rational number is denoted by like this Q with positive sign, and the collection of positive real number is denoted by this. So this is a collection of some numbers we can denote it by this capital alphabets. So we are discussing the set builder form. Now I will convert these sets. I will write these sets which is written in the roster form to the set builder form. See it very carefully. Now this is a set A, this curly bracket. Now see it very carefully. What are these elements? 1, 2, 3, 4. These are the first 4 natural numbers. So how I write it? Curly bracket x. Now I have to define what is x here, such that now x belongs to natural number. That is x is in the natural number, but there's a limitation in the natural number that there are first 4. So I will define the restriction that x should be less than equal to 4, or I can write x less than 5. So it means natural number less than equal to 4, that is 1, 2, 3, 4, and this is a set builder form of this set containing the element 1, 2, 3, 4. Now let us take this 2, 4, 6, 8, 10. If you see it carefully, they are the even numbers or a multiple of 2. So I write like this: set B is equal to such curly bracket x such that. Now I have to define x is equal to 2n, a multiple of 2. Now I have to define n. Now what is n? N is 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 5. That is n is the natural number. N belongs to natural number. 2 into 1, 2, 2 into 2, 4, 2 into 3, 6, 2 into 4, 8 and so on. And there is no restriction that there are infinite elements in this set. So this is the set builder form of this set B. Let us take another C. What we have in set C: A, E, I, O, U. These are the vowels of English alphabet. These are the vowels of English alphabet. So x such that x is a vowel of English alphabet. X such that x are the vowels of English alphabet in this set C. X such that x is a vowel of English alphabet. Now see it very carefully, this set D. Now 2, 4, 8, 16, 32, there are 5 elements in it. And these are the powers of 2. 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, and so on. So x such that, now what is x? X is 2 raised to power n. 2 raised to power n. Now what is n? N is 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. That is, n is a natural number. And how many elements are there? 1, 2, 3, 4, 5. So n is less than equal to 5. Means 2 raised to power 1, 2, 2 raised to power 2, 4, 2 raised to power 3, 8, 2 raised to power 4, 16, 2 raised to power 5, 32, like this. X such that x is equal to 2 raised to power n, n belongs to natural number, and n is less than equal to 5. So this is the set builder form of this set. Now this set E 1, 4, 9, 16, 25, 100. Now if you see it carefully, these are the squares of first 10 natural number. So I can write x such that x is equal to n square. The squares of first 10 natural number. That means n belongs to the natural number. N belongs to natural number, but there is a restriction in the natural number that the n is less than equal to 10, because the last number is 100, which is the square of 10. So it means n should be 10 square. So last n is 10. So n is less than equal to 10. So this is the roster form and the set builder of the sets, and we've defined. Now what is a set? Set is a collection of well-defined elements. What is a well-defined element? We'll discuss in the exercise of the NCERT. We'll take different examples to find the difference between the well-defined and not. If I take a set of a set collection of honest persons of the word, honest person of the word, the honest is not well-defined elements, so we cannot define that set. It is not a set. Now if I take you have to make a collection or make a set of the intelligent students of the class 11th. Now the intelligence, we cannot define word. What is intelligent? Intelligent not well defined, so we cannot make a group of intelligent students of class 11th. Now after that we have an empty set. Empty set is that set which contain no elements, or if there is a no element in a given set, it is denoted by this curly bracket, empty curly bracket, or a phi like this. Or I have taken if I take an example in the set builder form, b is equal to x such that x belongs to natural number and x less than 1, and natural number less than 1 is not there. No element is there less than 1 in the natural number, so it is an empty set or null set. Now if I put a curly bracket and in that I replace phi, that is it is not an empty set, because this set contain an element phi. So this is the definition and the set builder form and the roster form of a set. Now after that we have finite set. Now what is a finite set? Finite set, a set in which is empty or consists of definite number of element, is known as a finite set. Empty set is also a finite set, because we can tell how many elements are there in the empty set. None element is there, no element is there. Yes, 0 element in that set. So it is a empty, or in which we can count the number of elements in a set, is known as a finite set. For example, the set A 2, 4, 6, 8. In this we can count there are 4 elements in this set. Set B containing the element 1, 2, 3, 4, 5, and so on. It is not a finite set because we cannot count the number of element in it, so it is known as the infinite set. Or x such that x belongs to natural number and the natural number are infinite, so it is a infinite set. Now what are equal sets? Two sets are said to be equal if they have exactly the same element. Two sets A and B are said to be equal if they have same elements, exactly the same elements. For example, let a set A containing the element 1, 2, 3 and a set B containing the element 2, 1, 3. Now the elements of these two sets are same or exactly same, so these are known as equal sets. The order of the element is meaningless in a set. Now subset, this is a sign for the subset. This, see it very carefully. A set A is said to be a subset of B if every element of set A is also an element of set B. It means if all the element of set A is in set B also, then we say that A is a subset of B. For example, we have a set A which having the element 1, 2, 3, set B having the element 5, 1, 3, 2, 4, or 1, 2, 3 is in this set B. So we can say that A is a subset of B like this. A is a subset of B, or B is known as the superset of A. Now you have to learn it. Phi is the subset of every set. Empty set is a subset of every set. Empty set is a subset of every set. We'll discuss it in the exercise. Now, number of subsets of a set. How many subsets you can make of a set is equal to 2 raised to power n, where n is the number of elements in a set. Where n is the number of elements in a set. For example, if set A has element 1, 2, 3, so how many subsets we can make? How many elements are there in this set? 1, 2, 3. So number of subset will be 2 raised to power 3, which is equal to 8. Now, you have to, what are these subsets? Name those subsets for the set ABC. Now, as I already told you that empty set is a subset of every set. So, phi is a subset of this. This set containing the element A is a subset of this. This set containing the element B is a subset of this, because all the element of this in this set. The set containing the element C is a subset of this. AB is a subset of this. AC is also a subset of this. BC is also a subset of this, and ABC is also a subset of this. ABC, all the element of this set belong to this. So 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 subset of this set A, which contain 3 elements. Now, after that, we have power set of a set. Now, what is a power set of a set? It is a simple definition. It is a set of all the subsets of a set. It is a subset of all the subsets of a set. It is denoted by this capital P and in bracket A, means power set of A. That is power set of set A denoted by this. Now, let us take a set A which containing the element 1, 2. Now, you have to find the power set of this. So, first of all, find the subset of this set A. The subset of this set A will be, how many subset will be there? How many elements are there in this? 2. So, 2 raised to power 2, 4 subsets will be there. And they are empty. 1 in the curly bracket, 2 in the curly bracket, and 1, 2 in the curly bracket. Because 1, 2, 3, 4, these are all subset of this set. Because all the element of the individual set belong to this set. Now, what is the power set of this? You may